Hello guys, good evening all. Welcome back to this session of Pharma Analytics from 360DG. So in the last session, we have discussed about the logistic regression, how we're going to use that logistic regression in Pharma Analytics. And we have also discussed what is the predictive analytics when it comes to Pharma. And what are the benefits it will the analytics yields when it comes to the pharmaceutical industry. And we have also discussed what are the applications where exactly we can apply the pharma analytics in pharmaceutical industry. And we have taken one problem statement, that is prescribe a drug for pre-diabetic and type 2 diabetic patient using the historical data. And we have discussed how the data science project is implemented, what are the phases we'll be having when it comes to data science project, what is CRISP-ML, like it is a cross-industry standard process for machine learning. So whatever the field it is, whatever the field, whether it is HR, whether it is pharma, whether it is agriculture, any field, that is called cross-industry standard process for machine learning. Any field, data science project will be following the same phases, that is business understanding, data cleaning, data mining, model evaluation, deployment, and monitoring. These are the standard 6 phases when it comes to any data science project. So we have discussed that too in the previous class. And we have also discussed what are the stages of analytics. What are the stages of analytics when it comes to any analytics that are descriptive? You have to have a data that is historical data, and you have to go through that data that is called diagnostic analytics, and you have to come up with model, that is machine learning model, that is a predictive analytics. And we have to give business decisions based on the prediction that we are doing. Finally, we are doing the business decision that we have discussed yesterday in the previous session. So when it comes to logistic regression, I'll go through briefly because we will be discussing the logistic regression, how we are going to use that logistic regression in comes to pharmaceutical industry. We'll be discussing one use case, like we have given one problem statement previously. How are you gonna describe drug for pre-diabetic and type 2 diabetic patient? So even though the illness is same, but drug that you are prescribing, it should be based on the health condition of individual patient. So that is our problem statement, and that is one of the use case when it comes to pharmaceutical industry. We'll be building the one very basic model, very base model, and if you want to do modification in that you can do. We are just discussing what are the use cases, how are you going to apply the machine learning when it comes to pharmaceutical industry, that we will be discussing in this session. So when it comes to logistic regression, there are different types. when you have just one independent variable, that you can call as a random variable or input variable or input columns, anything. If you have just one input column and just one output, then it is called a simple logistic regression. When it comes to multiple, there will be, see, when it comes to model, we'll be having one dependent variable, and we'll be having multiple independent variable. All these called x1, x2, x3, x4. These are the independent variables, and when it comes to y, it is in a label, or you can call output variable. In every supervised case, supervised model, every supervised model, you will be having label, that is y. So if you have multiple inputs that are multiple independent variables, in that case, it will be called as multiple logistic regression. We will be having, when it comes to output, I think I have explained this yesterday as well in the previous session. So if you have an output that is just 2, yes or no case, that is bivariate logistic regression. If you have more than 2, that is more than 2 classes in the label, that is in output, that will be called as a multi-class classification. Multi-class. So if you have nominal data that has order, in logistic regression, in the output variable, that is label, if you have a nominal data and that data has an order, in that case, you will be going for ordinal logistic regression. So what is ordinal? You might have an idea about what ordinal data. In nominal data, you won't be having any order. Let's say any random number or jersey number of player. Let's say jersey number 7. Yeah, normally, see, if you talk about particularly in case of cricket, yeah, it will be Dhoni's number, but when it comes to other, it will be some other number. We won't be able to infer anything from that particular some random number. That is why we'll call is a nominal data. We won't be able to infer anything from the data. In that case, it will be called as a nominal. When it comes to ordinal, it follows some order. Let's say rank of military officials, rank of police department, yeah, similar. Both are similar. When you mention SI, CI, you might know, if you have an idea about the ranks, you might have an idea, right? CI is superior to SI. Constable, head constable, SI, CI, something like that. It has an order. When you use order data in case of output labels, we will be using the ordinal logistic regression. That is ordinal logistic regression. That you should know when you are having the ordinal data. Okay. We have discussed that too. See, this is when you have just two categories in your output. When you have just two categories in your output column, that is Y, that is dependent column, then it is called as a binary logistic regression. When you have more than three or more categories, in that case you will be called as nominal. If that nominal data has an order, in that case you will be calling as a ordinal logistic regression, like I have mentioned in a minute ago. So let's take an example. When it comes to nominal, it can be crunchy, mushy, crispy. So it doesn't have any order. Okay. It doesn't have any order. Nominal doesn't have any order. In the example, crunchy, mushy, and crispy doesn't have an order. So we'll call it as a nominal. When we have a strongly disagree, neutral, agree, strongly agree, in that case, it will follow some order. It is following some order, right? Agree, strongly agree, strongly agree. You can say it is, we are saying in a, compared to agree, we are strongly saying it is, I'm strongly agree. Opinionated, but we'll be having some higher priority to this one, right? Strongly agree. So we have an order when it comes to logistic, ordinal logistic regression. So we are using logistic regression for classification only. We are using the logistic regression for classification only, but why we are calling it as a regression? You might have this doubt in your mind. So why we are using the regression term when it comes to classification? In that case, so even though it is a classification, whatever the classification, whatever the logic we'll be following behind, whatever the logic we are following behind, it is similar to linear regression. Linear regression. When it comes to just one independent variable, it is simple linear regression. When you have multiple inputs, we are following multiple linear regression. It is similar. That output only we are converting into probabilities using the probability function. Using the probability function that we will see in a bit. So when it comes to probability, we'll be having, when it comes to probability distribution, we'll be having two kinds. That is one discrete probability distribution and one is continuous probability distribution. So when you are dealing with probabilities, when you are dealing with probabilities of discrete, discrete. The probability is discrete. When you are dealing with probability that is discrete, called as a discrete probability distribution. And when you are dealing with continuous, we are saying it is a continuous distribution function. So what is continuous and what is distribution? You might have an idea about it. If you don't have, let me explain in a minute. So what is continuous and what is discrete? When comes to discrete, anything that you mention in decimal and that doesn't make sense. That is called as a discrete. Let's say, for example, if I ask you how many people are there in your house, how many people are there in your house, then how will you respond? If you have 3, you will say 3. If you have 4, you will say 4. If you have 5, you will say 5. If you have a child that are like 2 years old, will you say we are 3 adults and half child? Will you say that? No, right? So you will be counting him as well, even though he's a child. You are counting that him as well. So overall, you'll say we are 4. So you can't mention the number of people are present in your house. You won't be, it is not possible to mention in decimal. That is why whatever things you won't be able to mention in decimal, it doesn't make sense. It doesn't make sense when you mention in the decimals. It is called as a discrete probability. When it comes to continuous, whatever the values that you are mentioning in decimal and that makes sense, it is opposite to discrete function. Let's say you have bought sugar. That is 1.5 kg of sugar you bought from the store. You are mentioning that how much you bought in decimal and it is perfectly making sense, right? It is making sense. This is called continuous. Whatever that makes sense if you mention in a decimal, that is called continuous probability. I hope you understood. Okay, let's move on to the next slide. So here I'm mentioning and representing that discrete probability distribution in graph. Let's say how many cars you have. Let's say we have taken 1,000 people and we are conducting a survey saying how many people have a car. Here you can say most of the people, let's say 1,000, that divide into 100, 200, 300, 400, 500. Let's say we have conducted survey for 1,000 people. Among 500 people don't have a car. People who have one car, about 100. People who have 2 cars, about, you can say 50. About people who have 3 cars, about 25. People who have 4 cars, let's say 10. Something like that. But whenever you are mentioning how many cars we have, We are mentioning in a discrete value, right? So you won't be able to mention the car, how many cars you have in decimal. Something broke down. See, one of the car you have that is broke down. Will you say one car is perfectly fine and one more car is broke down, so I'll give 1.5? Doesn't make sense, right? So it will be 2 cars. Like that, whatever the count you are mentioning, that is in discrete. When comes to continuous, go on to next slide. Yeah, when it comes to continuous, you can mention how height of the adult male in the world. You can say I am 5'6", I am 7'6". Yeah, it is not possible in India, but yeah, you can say 5'6", 6. I'm 6 foot 6 inches, 5 foot 6 inches, something like that. You can mention that is in a continuous. Okay, I hope you understand difference between discrete and the continuous. Okay, let's move on to very next slide. Logistic regression. So the use case that I am taking is logistic regression. How I am going to apply the logistic regression when it comes to pharma analytics. What is the logistic regression that we have clearly explained? What are the types also we have explained, we have discussed. So logistic regression model predicts the probability associated with each independent category. So whatever the independent variables will be having, that are random variables that you can call, those are input columns, also called as features, also called as a feature. What logistic regression do? Logistic regression model would do predicts the probability associated with each dependent variable. That is by label, you can say. Each dependent variable, that is label. So if we have 2 classes in output, we have 2 classes in our output. So it will predicts, logistic regression predicts probability of each dependent variable that we'll be having. We'll discuss what are the things, what data set that we have taken later, but here it will calculate the probability associated with different classes. How does it do? You just we might say we just mentioned about it is just simple linear regression, or here we are using multiple inputs, so it is a multiple linear regression. Multiple linear regression output will be the continuous one. That is obvious. Then how we gonna get a probability? You might have that out. So let's discuss how we gonna get probability output out of simple multiple linear regression. That output will be continuous one. So how we gonna convert? how logistic regression converts that continuous output into probabilities. That we will discuss. Here you can see how does it do this? How does it will convert that continuous data into probability? See, it will find linear relationship between independent variable and link function of these probabilities. Then the link function that provides the best goodness of it for that given data chosen. So first it will develop the relation between independent variable, that is input variable, and output variable, that is label. You can observe here, it is a simple linear regression. Normally, you will be getting one goodness of it when it comes to simple linear regression. These are the random variables. You can say X variable, and you will be having one regression line. A regression line, it is the best fit. We will do multiple iterations in order to find this line. When it comes to multiple linear regression or simple linear regression, for both we will be getting some regression line. But when it comes to logistic regression, we won't be getting that regression line. It should be discrete output, whether it is S or no, 0 or 1, some two classes, right? We are supposed to get that output. But linear regression line we won't be getting in case of logistic regression. So how it is converting linear regression output to logistic regression? That will be using the probability function. Probability function. Let's see what is probability function. See, when it comes to linear regression, multiple linear regression, the equation will be simple linear regression, it is mx plus r y is equal to f of x. Something like that. When it comes to multiple linear regression, logistic regression, multiple logistic regression will be having exactly same as it is when it comes to multiple linear regression. Multiple logistic regression model is quite similar to multiple linear regression model, but the coefficient beta, the coefficients vary. What are the coefficients? These are how much importance beta, how much importance we are giving to that independent variable. So each and every independent variable in logistic regression having one coefficient value. We will be creating that coefficient value using the model in a bit. So each and every individual value, independent variable, each and every independent variable having one coefficient, that is beta 1. If you have, let's say in our case, we'll be having, we'll discuss at that time only. Let's say we have x1, x2, x3 up to xk. That many beta values will be coefficient value we will be having. Here beta naught is the y-intercept. The model coefficient for the linear effect of the variable. How many inputs you will be having, that many coefficient you will be having. And E is the random error. So just we discussed how it is going to convert that logistic regression, multiple linear regression output into logistic regression. That we will be using cutoff value. That's probability function. Using the probability function. Cutoff value we'll discuss in a soon, like how the output, probability output will be converted into classes. That will there we will be using the cutoff value. So here the probability function. We are getting the multiple linear regression output using the probability function. Using the probability function curve. You just have observed, right? This is the curve. In case of where, yeah, here you can see this is the probability logistic regression curve. Using the probability function, the linear output is being converted into the probabilities. Here E is the real number constant. The basis of natural algorithm, E value is constant, that is 2.783. Y is the response value for the observation. Y is the response value of the observation. The probability in logistic regression curve, this is the probability function that we'll be using in order to convert that multiple linear regression into logistic regression. Logistic regression. This is how you will be getting the probability outputs. That are it. So normally you will be getting probabilities in between 0 to 1. The sum of the probability should be 1. Okay, so you will be getting the outputs in between 0 to 0.99 and 1. Yeah, when it comes to use case, okay. So here I'm taking one data set that is previously have discussed, right? Problem statement. Drug prediction for type 2 and pre-diabetic patient. So let me go through what are the data set, data description we'll be having. So here we'll be having multiple data, input variables. That is diabetic column, pre-diabetic, type 2 diabetic patient. That is an output for us. That is the input, and whether that particular patient has BP or not. If that guy or any particular person has a cholesterol or not, BMI, what is the body mass index ratio, and does he smoke or not? Does he had a stroke previously? That is same as heart disease, whether that particular has a heart disease or not. Will that is that particular person do the physical activity? If yes, 1. If no, it is 0. That particular person consumes the fruits regularly. If yes, it is 1. If not, it is 0. Does that particular person consumes veggies? If yes, 1. If not, it is 0. And if that particular person alcoholic, whether he is he consumes alcohol? If yes, 1. If not, 0. Health insurance, that particular guy has a health insurance or not? So normally it won't be useful when it comes to predicting the drug. So we'll be dropping that one, or we'll just hide that one. General health, I mean, how good his health is. Mental health, will be taking that too in consideration. Not thinking about your physical health, physical illness and injury during the past. Does that particular person undergone any operations previously, or any incidents, any injuries that particular person has? We will consider that too, and whether that particular person, male or female. Age, it is not necessary in the education column. So income is not also necessary. This is our output. That is targeted variable. So this is the description of that particular data set. And what are the independent variables we'll be using. So, yeah. So normally logistic regression output will be looks like this. Y is equal, it is a beta naught plus coefficient beta 1 into x1, beta 2, x2, something like that. And then we will be using the probability function in order to convert that multilinear regression output, that is continuous into probability. So even though when you convert into the probability, it will be the continuous value. Even though you are converting into probability, let's see how much value will be getting, like 0.1, 0.02, something like that. Something like that you will be getting, right? Even though you are converting into the probability, it is a continuous. So how we gonna convert that particular continuous value into classes? So whatever the target variables we'll be having 2 classes in target variable that we will be mapping, or we can use one-hot encoding to convert into discrete, that is 0 or 1. So whatever the output variable, whatever the output we are getting through probabilities, we will be setting some cutoff value. We will be setting some cutoff value. Let's say you have given a cutoff value. Let's say you have a given one cutoff value, and you are getting the probabilities. Okay. Yeah, you are getting probabilities like 0.01, 0.05, 0.1, 0.26, 0.5, 0.5, 0.9, 0.7, 0.5, 6, 0.57, 0.8, and we are giving some cutoff value, that is 0.5. If we are, this is the cutoff value that we are giving. So if you let's say you are getting the probability of random variable, or that is that of input, anything, take any input variable that we are using, input feature. If you are getting the probability value that is equal to or greater than 5, then it will be converted as one class. If you are getting equal to or greater than 0.5, In that case, it will be converted as class 1. And if you are getting the probability less than 5, if you are getting the probability less than 5, then that output is converted into the class 0. Yeah. So we are just setting some cutoff value in order to convert that probability value into classes. Class 1 or class 2. In this case, class 1 or class 0. I hope it is clear. Okay. So these are the coefficients when you are running the program, when you are applying that logistic regression on that particular data set. This will be the coefficient you will be getting. We'll certainly see that in a minute. So when it comes to pharmaceutical industry or any life sciences project, you are supposed to concentrate on this a lot, because true positive, true negative values impact a lot. Let's take an example, simple example. Cancer. You have built some model saying predict if that particular person has cancer or not. If in your prediction you have true positive values, yeah, you will be having true positive, true negative, false positive, and false negative. If it is false positive, what does false positive means? False positive means you don't have a disease, you don't have the disease, but it is saying you have a disease. False positive, you don't have a false positive, you don't have a disease, but the report came out that you have that disease. So even though you don't have, it is showing you have a cancer. In that case, you can go ahead and you can do a recheck. You can be cautious. You can be cautious. You'll go and you do one more check and all. But when it comes to false negative, when you have a positive, when you have a cancer, but it is saying you don't have. Even though you have a cancer, the output came out as you don't have a cancer. In that case, see, you will get relaxed. You won't bother about checking and all, because it is saying you don't have cancer. Then why do you worry about it? Right? You will completely forget about that, and it can be very detrimental. It can cause death as well. It is very detrimental and it can cause death as well. So you should be very concerned about when it comes to life sciences project that are true positive, true negative, false positive, false negative. All these things mentioned in a confusion matrix. Confusion matrix. You see, true positive, patient with the disease is told that he has a disease. Means you have a disease and you've been diagnosed as you have a disease. So it is a true case. I mean, you have a disease and it is predicted as a disease. In that case, you won't be having any issue. True negative. You don't have a cancer, and it is, I mean, the report also came as you don't have a cancer. In this case also, you don't have any issue. But when it comes to false negative, it can be detrimental. You should be very careful about it. It can literally cause a death. And when it comes to false positive, yeah, it can be dangerous as well, but not that, because you will be going for multiple checkups once you diagnosed with cancer. So you'll be knowing somehow after some time that you don't have it. So it can be, yeah, it is not that detrimental when compared to false negative. Yeah, I hope you understand. So from here only we will be calculating the accuracy. When you are working on that life sciences project, you have to be very careful when it comes to confusion matrix that are true positive and false positive cases. From here only accuracy. How we calculate the accuracy? Accuracy is equal to true positive plus true negative by overall. All of the cases. That is true positive plus true negative plus false positive plus false negative. Okay. So this is how you're gonna calculate the accuracy of that particular model, any model. But when it comes to life sciences project, you should be very careful about false negative, false positive. I hope you understood. Yeah. So it is also ROC, receiver operating characteristics. It is also one of the evaluation techniques. Say true positive cases, false positive, false negative, true positive. We'll be taking true positive in Y and false positive rate in X, and we are drawing one graph. The more it is near to the corner, the best accuracy it is giving. Yeah. Yeah, that is all when it comes to logistic regression. And how we gonna evaluate? When it comes to logistic regression, you have to be very careful when it comes to confusion matrix. Let's take one data set that is very base model. There are so many modifications that you can do, guys. I'm taking just very basic model, very base model, and I'm just going through how pharmaceutical industry, how we gonna implement logistic regression. Just a use case that is very basic model. Let's go through that. Yeah. Yeah. Yeah, diabetic. Yeah, you already have an idea about diabetes. What is diabetes? So diabetes is a serious chronic disease in which individuals lose ability to effectively regulate levels of glucose in the blood and can lead to reduced quality of life and life expectancy. After different foods are broken down, like how you might have an idea how sugar enters in our body. Once you have food, then it will be converted into sugars. Then it will enters into our body in order to produce energy. But in some people, to control that sugar, the insulin, whatever the hormone that controls it, it won't work properly. Because of that, we will be facing diabetics. So here the case, we are just recommending the drug to pre-diabetic and type 2 diabetic patient. So for that, first I'm importing NumPy. Of course, you need pandas in order to install or import files, and in order to manipulate, you need pandas, of course, and in order to do more, mathematical calculation, you would be needing NumPy. And for model selection, we have to split data set into train and test. So I'm importing the train test split. And from sklearn, like most of the algorithms we'll be using are present in the sklearn. So I'm importing the logistic regression from sklearn library. And in order to calculate metrics, I'm importing the accuracy score as well from the sklearn metrics library. Okay. So this is the data set, that is diabetic drug list. So here we'll be having 20 individual independent variable will be having 20 independent variable, and will be having drug as a by, that is label or output. Since it is a supervised algorithm, that too logistic regression. So logistics comes under supervised, so we'll be having one output. Just looking at shape. See, guys, we have to look for whether the data is balanced or not. I've seen it; it is balanced, so no problem. If you are going for, okay. Yeah, I think I have to balance this one. Okay, I have opened the different one. Okay. I think I have opened different file. Anyway, I'll explain you briefly what you are supposed to do. First, you have to check whether your data is balanced or not. If it is not, you can use small technique. I have actually used a small technique, but I think I have opened the different one. So, what small technique is? Synthetic minority oversampling technique. Synthetic minority oversampling. Whatever the minor variable will be having, that can be oversampled in order to make equal to 91 to 90. Okay, first you have to do that. And you have to check whether you have any categorical values or not. In that case, if you have any categorical values, you have to encode it. Here we'll be having just one, that is output. I'm using one-hot encoding to convert that label. In label, we'll be having what we'll be having in label. One is glimepiride and metformin. We'll be having two. One is, these are the medicines or drug, you can say, glimepiride and metformin. I'm converting that into classes using the one-hot encoding. That you will see. I'm checking whether I have any null values or not. So I didn't find any. And I'm checking whether I have any other objective data types. So most of them are integers only. So I don't need to change anything. When it comes to drug, it is a by output variable. I have to convert that into classes, that is in nominal or discrete value. That I did using the one-hot encoding. Okay. Describe function, what it will do. Most of the you will be known, right? what is the mean, median, standard deviation, how many values present in under 25%, under 50%, under 75%, it will show. Then I'm converting the whole data set into array in order to process very easily. Here, for output variable, I'm doing one-hot encoding in order to convert into label that you can see, that is output variable. These are the input functions. Sorry, input variables that are random variables that have converted into an NumPy array. See, when you going for regression, you are supposed to use the normalization using anything, min-max scalar, or any normalization. You'll be having normalization techniques, right? That you can do, because in regression you won't directly put those input values into the regression, because it has different values, like high range of values. But when it comes to decision tree algorithm, you can directly put. But when it comes to gradient descent based algorithms, algorithm, you have to convert into into same scale. Data should be in same scale that you can do using the min-max scale. That we are doing, and we are splitting the data into then we are splitting the data into test and train, and here we'll be having test for test 69, and the data is very less. Just to explain how you're going to apply the logistic regression when it comes to pharmaceutical industry. So it is a kind of toy data set. So yeah, don't take this one seriously. You can work on different data sets. You can find on Kaggle. There are so many data sets that you can work on. Then I'm calling the logistic regression function, so that we are calling the logistic regression in order to do the prediction, fitting the data into the logistic regression model, and we are getting. Here we are getting the accuracy. See, when you one more thing I'd like to mention, when your data set is unbalanced. When your data set is unbalanced, don't consider accuracy. First, balance the data set using some data set technique. Will be having a mode, advanced mode will be having, and there are different techniques. You can use any one of those, and you can convert. And here I'd like to show the coefficients. How much? The amount of coefficient will be having. How many coefficient? Each independent variable will be created one coefficient, like we have discussed in the linear regression, right? Y is equal to beta naught plus x1, beta 1 x1 plus beta 2 x2 plus beta 3 x3, something like that. So these are those, including the beta naught. So something like that. After that, you can go for confusion matrix. Plot one confusion matrix and see whether you have any false positive and false negative. False positive. Based on that only, you will be calculating the accuracy. But without balanced data set, don't consider the accuracy. I hope you guys understood, and that is the wrap, guys. And please go through try to build model based on pharma analytics. It will be very useful. You can add that into your resume. That will be that will add so much boost to that your resume. So thank you for joining us, and I hope you learned something from this session, and we'll see you in the next session, guys. And yeah, have a nice day and bye.